This is ISCI 2001, Chapter 16, Part B, Earth Surface. The themes for this lecture are the processes that tear down the surface, including weathering that is mechanical weathering and chemical weathering, and then erosion, which is mass movement, running water, glaciers, and wind. Processes that tear down the surface. These are slow, unnoticed processes such as downhill drift of soil on a slope, or constant shift of sand grains on the beach, or slow, steady dissolution of limestone by acid rain percolating through it. That's kind of what causes like sinkholes and stuff. But this is a log process. It's pretty slow. You can't really, you can't tell the difference day to day. This is an example of one where you can see the rocks that are, or the large boulders that are all around the large mountainous boulder that is there. This is a picture that was taken in Arizona, and the chipping off of the larger boulders was an overtime process. It wasn't like one day it was there and then one day it was down on the bottom of the cliff face. It was, it is a slow process. Weathering, these are the slow changes that result in the breaking up, crumbling, and destruction of any rock. The changes in rocks are caused by chemical, physical, and biological processes. Weathering is important and necessary because in the rock cycle, weathering produces sediment, which is the raw materials for new rocks. It's important for the formation of soils because soil is an accumulation of rock fragments and organic matter produced by weathering. And it's also important in the movement of rock materials over the Earth's surface. Weathering is important in preparing the particles to be transported by the wind or moving water. So weathering is very, very important. Without this, we would not have the regeneration of soils. We wouldn't have the sediment rocks for the rock cycle and different types of movement of rock. So this is important in helping different ecosystems stay viable. All right, and these are all examples. On the left-hand side, you can see the rock cycle. We've already been through it, but once again, you've got your sedimentary that will melt down into magma and lava. From there it can become the igneous rock. Through weathering, erosion, and deposition, you've got your sediments. But remember, this weathering, erosion, and deposition that it's talking about coming from the metamorphic rock and from the sedimentary rock and from the igneous rock. It is all necessary in order for this cycle to continue. You can see on the right-hand side at the top, it's got 3 different bands. It's got the white band, red band, and then white band again. The white band at the top, that's new soil. That's new soil that's being created from the rock that's below it. So it's very, very, very important, and not just from the rock that's below it, but also from the deposition, from sedimentary rock, from it being blown away by the wind, and things such as that, and it settles there to help form that new soil layer. And then at the bottom, you can see where that rock face, through the wind has eroded that rock face and has created actually indentions into it. So you can almost see the airstream pattern that is eroding this rock face. Mechanical weathering, examples of this include wedging effect, which is the repeated freezing and thawing of water in the pores and small cracks of otherwise solid rock. This is one of the reasons why if you go up north, places that have lots of snow and that also gets hot, an example right off the top of my head would be Missouri. That's where my husband's family is from. Their roads are made differently from ours. Ours is made from asphalt. Well, theirs isn't. It's made from concrete slabs that have spaces in between them that allows them to expand and to decrease in size whenever it's hot or whenever it's cold, so that it doesn't crack the surface. If they used asphalt like we use, then it would create cracks in the asphalt, and it's just not a very efficient way of doing their roads up there. But with rocks, it's the same way. When you see a rock that's been cracked or part of it's fallen off or whatever, it's usually from repeated freezing and thawing. And then the water in the pores in it, and that water pushes the rocks apart. The effects of reduced pressure, as more and more weathered materials are removed from the surface, the downward pressure from the weight of the material on the rock below becomes less and less, causing the rock below to expand upward, and it will fracture into sheets. So these are two different types of mechanical weathering, where you've got the repeated freezing and thawing, so the expansion and decreasing size of the water that's in the cracks, which pushes them away. And then you've got your more weathered materials where, as it breaks down up top, the bottom is relieved of some of the weight, so it allows that rock to expand more, and that makes it fracture. So those are your mechanical weathering. All right, look at the very top. You've got a glacier coming down through the mountains. Now, once upon a time, those mountains didn't look like that. They were more together, but because of these glaciers that are coming down, and it'll thaw and freeze and thaw and freeze and thaw and freeze, it has actually forced these mountains apart. And you can see down here at the bottom left, you've got the concrete that is broken because of the same effect: thaw, freeze, thaw, freeze, thaw, freeze. On the right hand side, you can see where the trees used to be under dirt or soil or rock or whatever, but because of the mechanical weathering, it's exposed the bottoms of those trees, and you can see the rocks that have broken off. Chemical weathering includes things such as oxidation, carbonation, and hydration. Chemical weathering changes the composition of rocks, often transforming them when water interacts with minerals to create various chemical reactions. Chemical weathering is a gradual and ongoing process as the mineralogy of the rock adjusts to the near-surface environment. New or secondary minerals are going to develop from the original minerals of the rock. In this, the process of oxidation and hydrolysis are the most important. So let's talk about oxidation. Oxidation, you can see here, within the weathering environment, chemical oxidation of a variety of metals occurs. The most commonly observed is the oxidation of iron, which is what you see here. It's where it combines with oxygen and water, and it forms iron hydrides and oxides such as geothite and limonite and hematite. This gives the affected rocks a reddish-brown coloration on the surface, which crumbles easily and weakens the rock. This process is better known as rusting, though it's distinct from the rusting of metallic iron. It's different from it, but we call it rusting. Many other metallic ores and minerals oxidize and hydrate to produce color deposits such as chalcopyrites or and oxidize into copper hydroxide and iron oxides and that kind of thing. With carbonation, rainfall is acidic because atmospheric carbon dioxide dissolves the rainwater, producing weak carbonic acid. In unpolluted environments, the rainfall pH is about 5.6. Acid rain occurs when gases such as sulfur dioxide and nitrogen oxides are present in the atmosphere. These oxides react in rainwater to produce stronger acids and can lower the pH to 4.5 or even 3.0, which is very acidic. Sulfur dioxide comes from volcanic eruptions or from fossil fuels. It can become sulfuric acid within the rainwater, which can cause a solution weathering to the rocks on which it falls. So some of the minerals, due to their natural stability or solubility, oxidation potential, or instability relative to superficial conditions, will weather through dissolution naturally, even without the acidic water. One of the most well-known solution weathering processes is carbonation, the process in which atmospheric carbon dioxide leads to solution weathering. Carbonation occurs on the rocks which contain calcium carbonate, such as limestone and chalk, which is very common here in the South. This takes place when the rain combines with carbon dioxide or organic acid to form a weak carbonic acid, which reacts with the calcium carbonate, which is the limestone, and forms calcium bicarbonate. This process speeds up with a decrease in temperature, not because low temperatures generally drive reactions faster, but because colder water holds more dissolved carbon dioxide gas. Carbonation is therefore a large feature of glacial weathering. And then we have hydration. Mineral hydration is a form of chemical weathering that involves the rigid attachment of hydrogen ions and hydroxide ions to the atoms and molecules of a mineral. When rock minerals take up water, the increased volume creates physical stress within the rock. For example, iron oxides are converted to iron hydroxides, and the hydration of anhydrite forms gypsum. Erosion. Weathering allows erosion to pick up and carry away fragments, clays, and solutions that have been produced from solid rock. The materials are moved to areas of lower elevation due to gravity. Mass movement or mass wasting is erosion caused by gravity. It can be so slow that it isn't even noticed. We call that creeping. And it can be fast and dramatic, which are like landslides, which are very, you've got mudslides and such in California, so it's common. All right, so here you have on the left a slow process that happens. That happened over a long period of time. On the right-hand side, this is a landslide that happened in California, and it obviously happened very quickly. It destroyed all the land around it, and very, very dangerous. Running water. This begins with rainfall that transports small fragments and dissolved materials across the surface. This material is transported to streams, then streams to rivers, and then rivers to oceans. Okay, so with the running water, what you've got is you've got the downpour of rain on the left-hand side, and then below that it goes into the stream. Now, keep in mind that as this water is running over these rocks, it is weathering them, and it makes them smooth. If you've ever noticed in a stream or in a river, the rocks are very smooth. They're generally not sharp, and that's because the water has weathered or eroded them down to a smooth, gentle surface. And from the stream, it goes to the river, and from the river, it goes into the ocean. Glaciers. Glacier is a mass of ice on land that moves under its own weight. Glacier ice forms from snow, and glaciers move slowly and unpredictably. Here's an iceberg. It's a part that chipped off from a glacier. The thing about icebergs is you're only going to see a very small portion of them. The largest part of them is going to be underwater. And it's because that ice is formed from water. It's in a saltwater solution, and it's going to just barely show the top part because it's the same density. Here you have a glacier that's moving. You can see on the right hand side that is water, and then everything around it is frozen. So it's slowly going into that river, but it's moving as a front. It's actually being pushed by the glacier that's behind it. So it's not that the river is pulling it or anything like that. The glacier is actually moving, and it's due to gravity. Wind, like running water and glaciers, also shape the surface of the land. It can erode, transport, and deposit materials. So here you have any dry climate is going to be very susceptible to wind erosion. So it'll be able to pick up things very easily and create, dust devils, that kind of thing that's almost like a tornado, and will erode the surrounding area very quickly. On the right-hand side, you can see the rock that is being held up by a small column, and all around it is where the wind has eroded the rock away. And it's because whenever the wind is blowing and it is picking up those sediments, it's almost like sandpaper when it's blowing. If you've ever been out west and you've been hit by wind that has any of that sediment in it, you know it doesn't feel good. It's not just wind, it's wind with rocks. Our GPS standard for lithosphere that we covered was to recognize and describe the different geologic processes that shape the Earth. Our hydrosphere standard was to understand and describe how weathering forms soil and how weather and erosion change the Earth's surface. The biosphere standard was to recognize and describe different biomes and how they're affected by weather, plant and animal activity, and geologic processes. Please don't forget to go to Georgia View and participate in your discussion and your weekly quiz.